On many commercial construction projects, HVAC and electrical systems install exactly as shown on the drawings. Inspections pass, and everything appears complete, until startup or final testing reveals that systems don't work together. At that point, the problem usually isn't installation, it's coordination. Small gaps between trades turn into RFIs, change orders, and delayed occupancy because responsibility for key items was never clearly defined. In this video, we'll walk through 5 of the most common coordination mistakes between HVAC and electrical contractors, why they happen, and how they can be prevented before construction even begins. The first and most common issue involves duct-mounted smoke detectors. Duct smoke detectors are physically installed in the ductwork, so they are often assumed to belong to the mechanical contractor. However, these devices require electrical power and must interface with the fire alarm system to shut down air handling equipment during a smoke event. Because 3 systems are involved, mechanical, electrical, and fire alarm, responsibility is frequently unclear. Mechanical drawings typically show the detector location, while electrical drawings may only show general power distribution. Fire alarm drawings may show monitoring points, but not the wiring path. The problem often appears during final inspection when the detector is installed, but the shutdown sequence does not function correctly. Building codes require that air-moving systems shut down upon detection of smoke to prevent distribution through duct systems. While the exact implementation varies by jurisdiction, requirements commonly reference the International Mechanical Code and NFPA 90A for air distribution systems. The key coordination issue is not the code requirement itself, but ensuring that power, monitoring, and shutdown wiring responsibilities are clearly assigned before installation. The second common coordination issue involves equipment disconnect switches. The National Electrical Code requires a disconnecting means within sight of motor-driven equipment. NEC Article 430.102b requires a disconnecting means located within sight from the motor and driven machinery location. Mechanical equipment such as rooftop units, exhaust fans, and air handlers therefore require local disconnects. The conflict occurs because mechanical drawings show the equipment, while electrical drawings may only show feeders or panel connections. Mechanical contractors often assume the electrical contractor includes the disconnect because it is an electrical device. Electrical contractors may assume it is excluded if it is not specifically shown. This issue frequently appears when equipment arrives on site and no disconnect has been provided, resulting in additional cost and schedule impact. Proper coordination requires confirming the disconnect type, rating, and mounting location early in the project, along with who is responsible. The third issue involves convenience outlets and service receptacles near mechanical equipment. Maintenance personnel require power to safely service equipment, and this requirement is addressed in the National Electrical Code. NEC Article 210.63 requires a 125-volt, single-phase, 15 or 20-ampere receptacle outlet to be installed at or near heating, air conditioning, and refrigeration equipment for servicing purposes. These outlets must be located within 25 feet of the equipment. Despite this requirement, service receptacles are frequently missing from electrical plans or assumed to be included without being clearly shown. The problem is commonly discovered during inspection or turnover when a required outlet is not present. Late installation can result in exposed conduit runs, additional roof penetrations, or coordination conflicts with finished work. Estimators should verify whether service outlets are included and clearly identify responsibility for providing and installing them. At this point, the coordination issues we've discussed are usually discovered during installation or inspection. The next 2 issues are different. These are the ones that often don't show up until startup or commissioning, when systems finally must operate together. And that's where coordination problems become significantly more expensive to correct. The fourth coordination issue involves control wiring and building automation system interfaces. Modern HVAC systems rely heavily on controls, interlocks, and communication between equipment. Electrical contractors typically provide power wiring, while mechanical contractors provide equipment, and a controls or building automation contractor provides system logic. The boundary between these scopes is often unclear in contract documents. Typical conflicts include who provides control transformers, who installs control conduits, and who pulls interlock wiring between systems such as VFDs, safeties, and shutdown signals. Because equipment may power up successfully without these connections completed, the problem often does not appear until startup or commissioning. When control responsibilities are not clearly defined, multiple trades may need to return to complete work that was assumed to be included by others. Clear scope definition during estimating prevents these late-stage coordination problems. The fifth issue involves fire alarm shutdown interfaces and system interlocks. Many HVAC systems are required to stop, start, or change operating mode in response to fire alarm signals. Mechanical drawings may indicate shutdown intent, while fire alarm drawings identify monitoring points, but the exact wiring responsibility is not always shown. The result is a system where equipment is installed and powered, but the required operational response does not occur when tested. This is typically discovered during functional testing or commissioning, when systems are required to operate together for the first time. The coordination challenge is determining who provides the relay, who runs the wiring to the equipment, and who verifies proper operation during testing. Without clear assignment, each trade may complete its individual scope while the overall system remains incomplete. Across all these examples, the underlying issue is the same. Drawings describe system intent, but coordination defines execution. The costliest problems between HVAC and electrical trades are rarely installation mistakes. They are scope definition problems that begin during estimating and carry forward into construction. For estimators and project managers, the solution is not to assume responsibility but to clarify it. Identifying coordination items early, qualifying proposals appropriately, and confirming responsibilities during pre-construction prevents small coordination gaps from becoming expensive field problems. Understanding where these issues originate is the first step toward preventing them. And in future videos, we will look at how many of these coordination problems begin during the design and estimating review process long before installation starts. Most coordination problems between HVAC and electrical trades don't start in the field. They start much earlier, when drawings are interpreted differently, or when responsibilities are assumed instead of clarified. By the time systems reach startup or inspection, the cost of fixing those assumptions is much higher than the cost of identifying them during estimating or pre-construction. If you've worked on projects where one of these issues showed up late, you've already seen how small coordination gaps can affect schedule, cost, and turnover. In the next video, we'll look at why many of these coordination items are not clearly defined on engineering drawings in the first place, and what contractors are expected to coordinate before installation begins. If you found this video helpful, be sure to check out our HVAC and plumbing estimating spreadsheets to streamline your construction bidding process. Check out our HVAC, electrical, and plumbing construction forms to help you run your business, and explore our online courses for in-depth training.